Cause of this velocity, that rate, 300,000 kilometers per second, 7.5 rounded Earth in 1 second. And this is our ordinary velocities. In ordinary life, this will be zero because they're so small. So we get back to this ordinary thing. And when this is zero, we also get back to this thing because we don't see that the watches are changing when we're driving by car. But if we take an atomic watch going with our fastest jet plane over Atlantic, the clock in the plane will go slow exactly as much as Einstein's formula showed. It's a billion of a second, but it's exactly what Einstein showed. So space is relative and time is relative. But you should say that idea that all is relative because it isn't. And I show that. What's happening now? Yeah. Now comes the most important concept of all, because I think this is what will replace the brain in space-time. I think I draw it here because more movement in it. I said before that physics starts to study simple problems. For example, taking two billiard balls, rolling together, and then hit and go back. So if we start here. After 1 second, the balls are coming here. After 2 seconds, well, they say they hit each other, and after 3 seconds, they go back. It's a very bad picture. But let it go like this. I said we couldn't point at time. But anyway, I can draw time as space, as a model. And this is space. So now, in reality, the balls are here. After 1 second they are here, but I draw it once they're up at the time 1. After 2 seconds they are here, but I draw it 2 steps up. And after 3 seconds they are apart, I draw it 3 steps up. I think my drawing is not very good, but I think you understand the meaning of it. So what we experience is two balls hitting each other like that. But in space-time, they exist already as full procedure. They exist as space-time sausages, let's say. And in a way which is not explained, our consciousness experiences like this. So we see two balls hitting each other. But in space-time, this process is already there. And why is space-time important? Well, Einstein showed that space is relative, time is relative, but this mathematics shows that space-time is absolute. The measurement in space-time is absolute, the same for everyone, whatever moment. And at this point, I can just say mathematically what space-time is, but in the end, I will show you that you already know what space-time is.
It can exist without observer.
What?
You mean the absolute? It can exist without observer.
Well, perhaps you could say, but actually I think it's the observer. But I can't.
It's space-time. It is observer.
Yeah, that's my end point. But I
okay.
Thank you. So I can go from here. So what next week?